Hi everyone, welcome back. Today we are going to discuss one of the most important assumption checks in two sample t-test or in ANOVA analysis, that is Levene's test for equality of variances. I'll show you what it does, when to use, and of course how to run it in SAS with clear interpretation of results. Let's get started. But before we jump into SAS, let's quickly understand what Levene test does. Whenever we perform ANOVA analysis, one key assumption is that all groups should have equal variances, also called homogeneity of variances. Levene's test checks this by testing the null hypothesis, that whether the variances are equal among the groups or at least one of the group variances is different. A p-value less than 0.05 suggests that the variances are significantly different, meaning the assumption is violated. The dataset which we are going to work on is an iris dataset. It is a classical flowers dataset with three different species. Let's see how does it look like and how we are going to use this dataset for Levene's test. PROC print data equal to wd dot iris obs equal to 10. Run the code. And as you can see here, there are four numerical columns: sepal underscore length, sepal underscore width, petal underscore length, and petal underscore width, and species, which is a categorical column. Let us use PROC contents statement. PROC contents data equal to wd dot iris tails run, and as you can see here, there are 150 records, 5 variables, and there different data types, what format it is, and species, which is a character data type. The variable of interest for us is petal length and species. We would like to analyze whether the variance of petal length is equal among the species or not. But before we conduct the Levene's test, let's do some basic descriptive analytics. PROC SQL select species min petal underscore length as min underscore petal underscore length, copy and paste. This is average. Let me change it to average. From wd dot iris group by species, quit. Let's run the code. And you can see here, for different species type, we have the min petal length, and for Setosa it is 1, Versic it is 3, and for Virgin it is 4.5, whereas average petal length for Setosa is 1.464, Versic is 4.26, and Virgin is 5.52. Similarly, you can see the standard deviation and the max underscore petal length. One thing is for sure, there is a difference in variance, whether it is significant or not, that will be determined by the Levene's test. But before that, let us build up a histogram and some basic descriptive analysis on a response variable, that is petal underscore length. For that, I am using PROC univariate test var petal underscore length normal mu equal to estimate sigma equal to estimate. Let us draw the kernel also. histogram petal underscore length title descriptive analysis of petal length. Let's run the code. And this particular piece of the code has given us some basic information about petal underscore length, which is number of records, mean is 3.76, standard deviation is 1.76, skewness and kurtosis. You can see the histogram, and by the look of it, it doesn't look normally distributed, and you can verify further by looking at the KS test, where the p-value is less than 0.05, hence it is not normally distributed for sure. Now we are going to run the Levene's test to check whether the variances are equal among different species or not. For that, we are going to use PROC GLM procedure in SAS. PROC GLM data equal to wd.iris class species model petal underscore length equal to species means species, and we are going to call the option here host test equal to Levene. So here what is happening, class tells us that species is a categorical variable, model petal underscore length equal to species sets up an ANOVA model, the option host test equal to Levene requires that Levene test for equality of variance is going to be tested. One can also specify type equal to ABS for the median based version, which is more robust to non-normal data. In our case, the data is not normally distributed. We should have been using type equal to ABS. But for this video, I just want to continue with regular Levene test, and that is why I am not putting here type equal to ABS. However, it is a best practice when your data is not normally distributed, you should be using type equal to ABS. Now let's run the code. Now let's look at the output. What we are interested in is this output. Here you can see the p-value. The p-value is less than 0.05. That means we reject the null hypothesis. The variance across groups are not equal. If the p-value were greater than 0.05, we would have concluded that the variance are roughly equal and we could have safely proceed with the ANOVA analysis. Since Levene's test failed, consider using Welsh ANOVA, which doesn't assume equality of variances. So to recap, Levene's test checks for equality of variances. It is easy to run in SAS using PROC GLM procedure and the host test equal to Levene option, and always interpret the p-value in context before running ANOVA. That's it for today. Thanks for watching and see you in the next one.